Hi and welcome to John's Maths book. In this video, I'm going to be looking at evaluating the indefinite integral of 1 divided by sin²θ d theta. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's look at how we find the indefinite integral of 1 divided by sin²θ d theta. To evaluate this, let's first divide both numerator and denominator by cos²θ. This gives 1 divided by cos² divided by sin² divided by cos². Now, using the trig identity, where tan theta is equal to sin theta divided by cos theta, and squaring both sides of this equation, we see that sin² divided by cos² is equal to tan²θ, which we can replace in the original integral. Now we can use U-substitution to simplify the integral further. So if we let u equal tan theta, the derivative of u with respect to theta, so du by d theta, is equal to the secant squared of theta. Using another trig identity, where 1 divided by cos theta is equal to the secant of theta, and squaring both sides of this equation, we can now replace secant² theta with 1 divided by cos²θ. It therefore follows that cos² du is equal to d theta. Replacing theta and d theta in our integral, we have 1 divided by cos² multiplied by cos² du, which is the replacement for d theta, and that's divided by u squared, where u is equal to tan theta. Cos² in the numerator is eliminated, and we're left with the integral of 1 divided by u squared du. Using the power rule to evaluate this, we have minus 1 divided by u plus a constant of integration. If we now substitute back in for u, we're left with minus 1 divided by tan theta plus a constant of integration, which is our final answer.